Hello guys, as I'm still not employed, so let's solve today's lead code question. This is a hard level question. So they have asked us to find the count of vowel permutations. So the vowel permutations, in the sense, we'll have like 5 vowels, A, E, I, O, U, and we have to give a number of permutations of n n sized strings that can be possible from the given vowel letters following the given conditions. So permutations, as we know, rearranging them in such a way that we get maximum outcomes. So they have given us an integer n, and they asked us to find the task to count how many strings of length n can be possible from the given vowels using the following conditions, that are like A should be followed by only E, and E should be followed by only A and I should not be followed by I itself, and O may be followed by I and U, and U may only be followed by A. So we should follow these conditions, and for the case where we have given n is equals to 2, the following outcomes will be like these, which all of them will follow the above conditions. So from the above result, I understood that if n is equals to 1, then our case is very simple. It will be only these 5, and if n is equals to 2, then we'll have we have to check these conditions. Conditions, when we have to check them, I got to this idea. So that is like, if we have a hash map of all the letters for A, E, I, O, U, and in the hash map for each letter, for each vowel, we can have the possible outcomes followed by that particular letter. So as we know, A should be only followed by E, so I will add the hash set element E, and I will put it into the hash map of A. And the same goes to E also. E should be followed by A and I only, so we have added A and I into the hash set, and we have added the possible outcome for the E in the hash map of E. And the same goes for I also, only except I, other things are followed, that's why we have added. And for O also, except I and U only will have in the followed condition, so that will be added for O, and for U also the same. Now when I checked in an intuition purpose, I have understood this. So what is, like, if at all n is equals to 3, okay, if n is equals to 3, then we will have 3 positions. So if we take A in this case, so then A should be followed by only E, so that means definitely the second position will be E, and E can be followed by both A and I. That means we have two conditions, so that means the total number of outcomes are 2 for A. And for E, in the case if we have E in the first position, then E is followed by 2, right, A and I, and A is followed by only E, and I is followed by 4 others except for I. That means our total outcomes are 5, 1 plus 4. Similarly that goes to I also, similarly that goes for O also. That means here, if at all after A there are n possible ways, after A there is only one possible case, but in the worst case, what will be our case? In the worst case, only I might be there here in the worst case, and in the second case, except for I, everything is possible, right? So that means we can have E, we can have O, or we can have anything. That means the next position might be, if we consider the next position also in the worst case I, and the third position also I, that means we have 4, 4, 4. That means in the worst case we have 4 power n only, right? So that means our time complexity in the worst case, this is not even possible, but we are thinking 4 power n, right? So that means we have to make our time complexity as simple as like the following. So if at all we want to reduce this thing, how can we do it? Do we have any other intuition other than looping into the hash set or hash set? I don't think we have any. But if at all the n size is small, then our possible outcomes are less. If not, we have more possible ways. And if n value is increased, like the more the n value, the more the time complexity, right? So let's solve this question. Let's go. So my first approach on this question was backtracking. So I have tried n queen and other backtracking questions based on generic algorithm and other things. So backtracking is nothing but like we can dynamically create for loops in backtracking. That's the only thing. Backtracking approach mainly used in the case where our answer might depend on the previous outcomes. So the way we loop the next iteration will be depending on the previous looping iteration. So in that way it will be like for loop under for loop under for loop under for loop until n times. Okay, but we can't directly write for loops n times, right? Our code doesn't work like that. So in order to dynamically write those for loops, we normally use recursion. Recursion notations really help in dynamically assigning for loops, which is the very reason why we are using backtracking in using recursion. And if at all our code really stops at a particular location, it will come into the initial position again and will again run the for loops, recursion, right? So that's the way backtracking works. So what I have done is like I have already created that hash map and hash map of hash sets, right? So hash map in hash map, the character will be the first element. First element might be AEIOU. So and the hash set will contain the next coming set of elements that are possible after that particular character which we have. So that hash map will contain a character and a hash set of possible chances, right? So my code will first take the index position 0 and it will loop through, like if at all there are any possible chances, then what it will do is like it will go into those possible chances. That means after A there are two possible chances, E and I. Then what it will do, the for loop will take both E and I, and for E there will be a loop into, so the position will be added as 1 and then the same recursion will happen. Similarly for the position 1 we'll have I also, which is another possible case. So it will perform two recursions within that function, within my recursive function. Okay, so if there are certain in the case of I, we have A, E, O, U. So all the four recursion functions will be called within the recursion function which I have. Okay, so that's the way it works. So whenever I get to the end of the string, the size, whenever the position size is equals to n, what I will do, I will return 1. Okay, so whenever I am in the last index, whenever the position is equals to n minus 1, that is the last index, I will return the count as 1. So every time when I count those things in the for loop, the count will, I add my count value with that of the next position's count which I get. Okay, so in that way my code will run loop into, but there was time complexity error. So I understood, okay, my code is not optimized. It's running like around n factorial. If at all is the worst case, there are some conditions, that's why I think it will be like around 4 power n. So 4 power n is the most worst scenario. So that is not optimized in a way, because there are certain cases where if you consider A and E, and if AE after E if there are 3 positions, that means n is equals to 5, then my code will be there will be a second case where if we have I in the first position and later we get E, after E the number of possible cases will be same, right? So in a position in a particular position, a particular element will always have the same number of counts, same number of possible outcomes, right? If you use backtracking. So that's why we can directly use DP, memorization. So that is the reason we are using memorization technique. What it will do is, if it is already reached before, if that position was already visited, we don't need to visit it again. It will reduce our time complexity. So then after we use that recursion of DP, our outcomes will be reduced to around n itself, right? N is itself. So our position of that value will be n, the number of possible visiting cases will be n factorial, so our values will be like n factorial. Got it? so the time complexity will be n factorial in that way if you perform. So using this memorization technique is really important in the case of backtracking, because backtracking always takes a lot of time complexity. So we should always check if at all those things are already visited, why you are visiting again. So that's the really important thing. So try to reduce as much as possible. So always use backtracking along with memorization. So I have tried 2-3 outcomes. Later I found like they have asked us to find the ASCII position. So then I used the ASCII position. We can directly take hash map also, but I don't want to use it. I directly took the index position of the vowels. So as we know, ASCII position of A is equals to 97 and B is equals to 98. In the same way until 122. Okay, so I directly given my array size is equals to 122. So in that particular index position of A, which is 97, I get my value. So in that way I have used the memorization technique. Later I got my answer, but they asked us to take the modulus of 10 to the power 9 plus 7. So I had taken it again, then I got my answer right. So if you can see, I've been waiting to solve this question for a long time. And luckily I got my answer right in the final phase only. So it's really important to add your answers to the community forum. So I generally do it. And when I was solving this question, right, so I saw negative values. Why did I get negative values? I was shocked. My code always adds up, but it will never subtract, right? Taking a count will never be subtracted, right? So then I looked into my code. Then I found my code is taking modulus of an int, but when the number size itself is 10 to the power of 9 plus 7, more than 7, then why we are taking int? We should take long, right? So long will take up to 10 to the power of 19, right? So that means that's why I'm getting negative value. That's why my code is partially optimized. So what I have done, I have took the long variable after which my answer got right. Then I given my time complexity and everything. Taking time complexity or backtracking is really tough, man. Like how can you loop through everything and visualize everything in mind? It's not really easy. So try to train yourself to get the time complexity of any type of question, right? So by looking at the question itself, we should be able to understand this might be the time complexity of that question. So try to work hard, get it done. Yeah, thank you. Bye bye.